Welcome everyone. In this video, we'll be starting with the activity 2.1 and we'll be covering the first three questions of the activity. So all these questions are based on determinants. So let's get started. The first question says that we are given a matrix A of order 3 cross 3 and few entities P, Q, R over here, where Mij denotes the minor with respect to the ijth entry. So before we delve into the question, there are few points that we can discuss over here. So maybe I'll use a different slide for that. So here, if I want to find the determinant of a particular matrix A, so that could be found using summation of Aik times Cik, where your k ranges from 1 to n being order of the matrix, order of the matrix A. And this is true for all I equal to 1, 2 till n. That means I can pick any particular row. For example, if I take I equal to 1, that means if I pick the first row and I can expand my determinant along the first row. So it is A11 times C11 plus A12 times C12 plus A13 times C13. So it is basically expansion of the determinant along the first row. For example, if I want to do along the third row, I can take I equal to 3 and it would become A31 times C31 plus A32. Here you can see that I is fixed but K is changing. 32 times C32 plus A33 times C33. Okay, and this is not just true for the rows, this is also true for the columns. So I can also write it as summation of Akj times Ckj, where your k ranges from 1 to n, and again in the order of the matrix, and it is true for all the values of j ranging from 1 to till n. Okay, so for example, if I expand along the column 1, it would look something like this. So A11 times C11 plus here this time k would change. So A21 times C21. Here you can observe that j is fixed and we have fixed j as 1 plus A31 times C31. Okay, so this is expansion along the column and this is expansion along the rows. In all of the cases, the value that we will get is going to be same and that value will be equal to the determinant of A. Now, since here in the question 1, everything is represented in the form of minors. So what will happen if we try to represent the same thing, not in the form of cofactors, but in the form of minors? So see, this thing we know about the cofactors, that cofactor of ijth element is nothing but minus 1 to the power I plus j times minor of ij. So if we use the same concept over here, so C11 would be minus 1 to the power 1 plus 1, that is an even power, so it will be just positive sign A11 times M11 plus. Now it is going to be minus 1 to the power 1 plus 2. So 1 plus 2 is 3, which is an odd power. So uh, it is going to be minus 1 to the power 3, that is minus 1 again. So minus 1 into A12 times M12, and similarly 1 plus 3 is 4, which is an even power. So it is just 13 times C13, not C13, M13. Okay. So let's see, can we see some similarity over here? That is minus 1 to the minus 1 into M11. Uh, and what is minus 1? Minus 1 is basically the first element over here, which is my A1. What is 2? 2 is my A12. What is 0? 0 is my A13. So if I expand it along the row 1, it is going to give me determinant of A as minus 1 times M11 minus of 2 times of M12 plus 0 times of M13, which is the exact same thing that we have seen over here. Now, similarly, I can do for row 2 as well. So if I do along the row 2, I will get here this time it is minus 2 times of M21 plus of 0 times of M22 minus of minus 1 times M23. If we expand it along R3, we get determinant of A as minus 1 times M31 minus of 0 times M32 plus 1 times of M33. So if we observe carefully, this is nothing but our P, this is nothing but our Q, and this is nothing but our R. So here we can see P equal to Q equal to R, and all of them represent determinant of A. So this option is correct, this is incorrect, this is incorrect, and this is also incorrect. And regarding the first part where it is asking us the value of the determinant, so we can evaluate it very easily. So to find the determinant of A, we will expand it along the second column. So if we expand it along the second column, it is just minus 2 times of this small determinant, 2 minus 1 and 1, which is basically minus 2 times of uh, 2 minus 1, which is minus 2. So determinant of A is equal to minus 2. So this is also correct. So we have seen that P is equal to Q is equal to R is equal to determinant of A, which is again equal to minus 2. This was all about question 1. Now let's move on to the question 2, where it is given that suppose A is a 3 cross 3 real matrix. So there exists a 3 cross 3 matrix P such that D is equal to P times A times P inverse. It's a real diagonal matrix. Okay, so it is given to us that D is a diagonal matrix. Now we have to choose the correct set of options. The first option says determinant of A must be equal to determinant of P. So let's check that. So if we start with D equal to P times A times P inverse, and if we take determinant on both the sides, we get determinant of P times A times P inverse, which is nothing but determinant of P times determinant of A times determinant of P inverse. And we know that determinant of X inverse gives us 1 over determinant of X. So here we will get determinant of P times determinant of A times 1 over determinant of P. So one may ask a question over here uh, that what if the determinant of P is 0 and 1 over determinant of P will not exist in that case, but because it is already given to us that P inverse exists, that in itself guarantees that P is the determinant of P is non-zero. Okay, so these two things will cancel out each other and we are just left with determinant of A. So one conclusion that we can deduce from here is determinant of D is equal to determinant of A. So that means option 2 is correct, but we have not obtained any solid proof for option 1, so we will mark it as incorrect. Now, uh, the option 3 says the matrix A must be equal to D, which is incorrect. See, here we have seen the determinant of both the matrices should be same, must be same, but it does not mean that both the matrices must be equal to each other. Because we can have multiple examples that we have seen in the week 1 as well, that if the value of determinants of two matrices are equal, that does not guarantee that both the matrices are equal to each other. Okay. Now, moving on to the fourth question, fourth option, where we have if D is the identity matrix of order 3, then A must also be an identity matrix of order 3. Now, what about option 4? So in the option 4, it is given that D is an identity matrix. So what was D? D was P into A times P inverse, which is equal to I. So what we are going to do is, we will first pre-multiply with P inverse on both the sides. Pre-multiply with P inverse on both sides. So by doing this, we can get P inverse times P into A times P inverse is equal to P inverse times I. So here, what we were trying to do is we are trying to group the inverse term and the non-inverse term together. So here P inverse is grouped with P. To do that on the later part also, we can post multiply with P. So post multiply with P on both sides. So that would fetch us P inverse times P times A into P inverse times P, which is equal to P inverse times I into P. So here we can see that P inverse times P will give us I times A times P inverse times P will also give us I, which is equal to P inverse times I will give us P inverse again times P. And here we have P inverse P is equal to I times A is A again and A times I is A again. So A is equal to I. So if we start with D equal to I, we can prove that A is also equal to I given D is equal to P into A into P inverse. So that means option 4 is correct. Okay, moving on to the question 3, we have to choose the correct options for a square matrices of order 3 cross 3. That means A and B both are square matrices. So if A times B is equal to 0, then one of the matrices between A and B must have determinant as 0. Okay, so what about option 1? So if we have A times B equal to 0, so if we take determinant on both the sides, it would be determinant of A B equal to determinant of 0 matrix, which is equal to 0, and determinant of A times B is equal to determinant of A times determinant of B. Now, you have two entities and product of two scalar value is equal to 0. That means there are only three possible cases. One is A equal to 0 and determinant of B not equal to 0. The second possibility is determinant of uh, B is equal to 0, but determinant of A is not equal to 0. And the third possibility is both determinant of A and determinant of B are equal to 0. So in all the possible scenarios, there must exist at least one of the matrix in A and B such that its determinant is equal to 0. So one of the matrices at least should have determinant equal to 0. Yeah, this option is correct. Moving on to the option 2, we have uh, both the matrices must have determinant equal to 0. No, this is incorrect. We have seen that this possibility will also work. Okay, moving on to the option 3, here we have AB is equal to 3i, then which of the following is correct? So let's check it. So we are given that uh, AB is equal to 3 times of 5. So if AB is equal to 3 times of I, we can take determinant on both the sides. That would give us determinant of 3 times I. Uh, determinant of A into B is determinant of A into determinant of B, which is equal to, uh, again, I is a matrix of order 3. So if we take 3 out of this determinant, that is going to give us 3 times 3, 3 to the power 3 times determinant of I. So determinant of I is equal to 1. So it is basically equal to 27 only. So two scalar quantities getting multiplied with each other to give 27. So that guarantees us one thing, that determinant of A and determinant of B both are not equal to 0. That means uh, A inverse and B inverse both exists. If we continue with the question, we can write a determinant of A as 27 divided by determinant of B. So this is our solution. So let's check which option has this. So option 3 doesn't have it, 4 doesn't have it, 5 has it. So option number 5 is correct. What about option number 6? It says if it is equal to 3i, then both must have non-zero determinant. So this we have shown over here. So this we just showed here that determinant of A and determinant of B both are non-zero. So this was all about question 3. So we have completed the first 3 questions of activity 2.1 in this video. We'll see you in the next video. Till then, have a nice day. Bye.